Okay, these notes start the beginning of Unit 8, Trigonometry. This course, Algebra 3 with Trigonometry, has trigonometry thrown in as well to prepare you for the next level of mathematics. Some schools offer trigonometry as a course in itself, which would cover a lot more in depth. So what we're going to do here is give you an introduction in trigonometry. Some of this you've had, and some of it is brand new. So the new part for most of you is thinking of angles other than just a triangle. So we're going to talk about angles that have nothing to do with triangles to begin with. And an angle that's in standard position is going to be graphed on an XY coordinate plane. So if I were to draw the XY coordinate plane, this being X and this being Y, an angle that's in standard position is going to start on the positive x-axis. So if I started on the positive x-axis, I'm going to start right here. This would be called my initial side. And that angle is going to go in either counterclockwise or clockwise direction. But if this angle starts here and goes in this direction, counterclockwise, it's going to end at the terminal side. And the arrow on the angle actually shows me the direction the angle has moved. So think of it as a tire that's spinning around and round. And this arrow is important to show direction. And we refer to this angle as theta. So theta is the angle. In geometry, you typically used x. Most of the time, we're going to use theta or other Greek letters. When we draw angles, we can draw positive angles, and they're going to rotate in the counterclockwise direction. So if I had an angle of 70 degrees, if I think of it, starts here on the positive x-axis, and to make a right angle, we go all the way here to 90 degrees. But I don't want to go to 90, I want to go before I get to 90. So it would stop in this direction. And this would be 70 degrees right here. So theta is equal to 70 degrees, and it's a positive angle. And I think one of the best ways to remember which direction is positive is when you're talking about quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. So this angle is moving from quadrant 1 to 2 to 3 to 4. So if I wanted to draw another angle, say 250 degrees, I'm going to start here. If I go here, it's 90. Halfway around a circle is 180. All the way down here is 270. So I have to stop before I get to the y-axis. And it's going to look like that. So theta is equal to 250 degrees. I can have angles that are larger than 360. So if I draw my XY axis, let's do 500 degrees. So 500 degrees, if I start here, all the way around a circle is going to be 360 degrees. Notice I didn't stop right here where I started, because otherwise I would just draw a circle, but I need to show that this angle is greater than 360 degrees. So I need to go another 140 degrees. All the way over to here is 180, so I just have to go about 40 degrees off of that, which is going to be about right here. So this is theta is equal to 500 degrees. Angles that rotate in a clockwise direction are referred to as negative angles. So positive and negative are just going to be a direction. if I wanted to do negative 30 degrees. So I still have to start at the positive x-axis, and I now go in the clockwise direction. I go about 30 degrees. Notice I'm not getting a protractor out and measuring these. I'm just drawing about where they are. As long as you're in the correct quadrant, you're okay. So negative 30 degrees. Actually, let's make sure I write that as negative 30 degrees. It's going to be in the fourth quadrant. And let's say I want to do negative 410 degrees. So once again, I start on the positive x-axis. I'm going to go clockwise. All the way around is 360 degrees. But I need to go another 50 degrees. 360 plus 50 gives me my 410. It's going to be about right there. So if theta is equal to negative 410 degrees. The other thing that's new for many of you is talking about angles in radian measure. So if we have a circle, and I travel all the way around that circle, I'm going to go 360 degrees. That's one revolution. If we were to do it in radians, the circumference of a circle is 2 pi r all the way around. So r is just that distance around. So my angle is going to be 2 pi radians, is one revolution. And this is like, it's like learning a new language. I think better in radians because I use it more often. Upper level math classes, certain sciences will use radian measure more than they will degree measure. So it's just something to get used to. When I say 2 pi radians, this is an exact radians. Your book will say that it's a multiple of pi. And that's really common. SATs, college placement tests, understanding this idea of pi is just a number and you don't have to put in the value 3.14. If I wanted to get the approximate radian value, I would take 2 and multiply it by 3.14. So 6.28 would be my approximate radians. And it can be rounded to whatever value you're asked to round it to. I typically go to 2 decimal places. So what happens if you're going to go halfway across a circle? If I cut this circle in half, it's going to be 180 degrees. If I cut this circle in half, it's going to be pi radians. So that's what's going to be important when we convert. 180 degrees is going to be equal to pi radians. So here we are, we're going to be talking about converting now. If I want to convert between radians and degrees and I'm asked for the exact value or the multiple of pi, I'm just using 180 degrees is equivalent to pi radians. So if I had 45 degrees and I want to convert it to radians, I'm going to multiply by pi and divide by 180 degrees. To show you what that looks like on the calculator, you don't need to use the pi symbol. I'm going to do 45. Let's do it this way. 45 divided by 180. The calculator will reduce it for me. It gives me 1/4 pi. So this is going to equal pi over 4, or 1/4 pi. If you have the pi symbol, it's understood that the units are radians. So you have to be very careful when you're using units in this section. If it's in degrees, you must use the degree symbol. If you don't use the degree symbol, it's assumed that you're using radians. If I wanted to look at negative 120 degrees, I multiply that by pi and divide by 180 degrees. So negative 120 divided by 180, calculator will reduce it for me. So negative 2 pi over 3. Let's do one more. How about 450 degrees? Once again, multiply by pi and divide by 180 degrees. And notice this, you have degrees in the numerator and degrees in the denominator. So you get rid of the degrees and all you have left is the pi. So then if I take and reduce 450 divided by 180, I get 5 over 2. So I get 5 pi over 2. I can also convert between radians and degrees when it's an approximate value. So if I had 5 pi over, let's go back a second. I forgot I want to do degrees. This was degrees to radians. If I want to do radians to degrees. So let's say I had 11 pi over 9 radians, and I want to convert that to degrees. I'm going to multiply it by 180 degrees and divide by pi. So I'm left with degrees because pi's cancel out. I do 11 times 180. Let's do 11 over 9 times 180, and I get 220 degrees. And I have to use the degree symbol. During the live lesson for this, I will give you more examples. Now let's look at degrees, between radians and degrees, approximate value. So if I had 72 degrees, and I want to convert that to radians, I'm going to multiply by pi and divide by 180. So the difference is here, I actually want to use the pi symbol. So I have 72, oops, times pi divided by 180. I get 1.2566. So I'm going to just round that to 1.26. And this is in radians. If I wanted to convert, I don't know, 41.813 degrees. I'm going to multiply by pi and divide by 180 degrees. And I'm trying to get it where there's not a glare. So 41.813 times pi divided by 180. 0.72977, so 0.73 radians. I can also convert from radians to degrees. And it's the same process. Let's say I want to take 5.16 radians. So now I'm going to radians degrees. I have to multiply it by 180 degrees over pi radians. So 5.16 times 180 divided by pi. Notice I'm not putting a degree symbol in here. There's a lot more I could do with the calculators, and I'm not going to show you everything. I just want you to understand the process. So I'm not using a degree symbol. And that's equal to 295.6 degrees. I started with radians and I went to degrees. So we're also going to use the term coterminal angles. Coterminal angles are going to be angles that start at the same place and end at the same place. So let's draw an angle. Let's start out with a 40-degree angle. So 40 degrees looks like that. I can come up with a coterminal angle. Has to start here and end here, but I can just go in the other direction. If I go in the other direction, I have a negative angle. So it still starts and ends at the same place. How I got that was 40 degrees minus 360 degrees, which is equal to negative 320 degrees. I could also start here. Instead of stopping there, I can go all the way around and continue further and end at the same spot. So I would do 40 degrees plus 360 degrees. So that gives me 400 degrees. And I can continue to do this forever and never run out of an angle. I could just keep going round and round and round. It get very sloppy looking on my picture, but coterminal angles, there are infinitely many of them. We could do this in radians as well. So here's my XY axis. I'm going to start with an angle 7 pi over 6. So 7 pi over 6 is about right here. Because 6 pi over 6 is right to here, and I have to go a little bit further. So this angle is 7 pi over 6. I can get a coterminal angle by going in the opposite direction. So to get that, I'm taking 7 pi over 6, and I'm going to subtract 2 pi. 7 pi over 6 subtract 2 pi is going to give me 7 pi over 6 minus 12 pi over 6. 7 minus 12 is negative 5. So negative 5 pi over 6. It's the angle I drew in the pink. And like I said, there's infinitely many of these. So I could go in the same direction I did the first time, but instead of stopping at the terminal side, I'm just going to keep going all the way around and come back to it again. So that would be 7 pi over 6 plus 2 pi. Get a common denominator, 7 pi over 6 plus 12 pi over 6. Gives me 19 pi over 6. Coterminal angle seems like a very simple, and it is a very simple concept. When it gets applied in other problems, sometimes students will forget what they're doing with them. So like I said, this is mostly just an introduction to radian measure. The last thing we're going to do in this section is talk about arc length. You did this in geometry. So what you've got, if this is a circle, S is this arc length here. It's the measurement of the outside of the circle. So it's part of the circumference. So that's where we get this formula. The part of the circumference is S. The whole circumference is 2 pi r. This r here is a radius. This angle here is theta. And we're not going to worry about direction on this. We're just talking about the magnitude of it. So it's going to be a positive number. So this theta, sometimes called the angle subtended, is going to be part of the circle. All the way around this circle is 360 degrees. So we can set up a proportion. Theta over 360 equals S over 2 pi r. That's where this formula comes into. That's when theta is in degrees. This other formula happens because remember 360 degrees is equivalent to 2 pi. So if I change this to 2 pi, this 2 pi and this 2 pi can be canceled out. And that's where I get theta equals S over r. So those are the formulas that are used. And this formula is when theta's in radians. Okay, the live lessons that go with this, they're really important to watch because this is an overall, and on the live lessons, I will give you exact instructions on how you're going to do the work for that day in class.